Hello everyone. In this video, we will be covering the topic of guards in Nest.js. So with the name, you would understand that it has something to do with the security. So let's move forward. So you see, this is the client which sends an HTTP request to our Nest.js ecosystem, right? So previously we learned about middlewares as well as pipes, but there is one other concept that we have not learned, that is interceptor. So all of them fit one by one, and which will we will cover how this sequence actually works in this entire request response life cycles after all of the topics are done. So let's see where does guards fit. So when the HTTP request is sent, guard is in place at the frontier door, for example, and it is executed after all of the middlewares have been executed, but before any of the interceptor or pipe is supposed to execute. So it sits in the middle of it, right? So what is actually the goal of guard? So the goal of guard is to perform authorization. So there is a minor difference between not minor, but a major difference between authentication and authorization. So the guard's responsibility is about authorization mainly, right? Authentication means authentication verifies if a user or an entity exists within a system. So it can authenticate with, for example, your username or password, but authorization means to verify if that particular user or an entity has a permission to do some task. For example, you can log into your Facebook. So the login process where Facebook system verifies whether you are a valid entity or not is supposed to be authentication. But once you are logged into a system, right, you can see many pages and many posts. You cannot just go ahead and delete anyone else's post because you don't have that permission. So that scenario and that behavior is the behavior of authorization, to verify if you have a permission to do certain task or not. So all of this authorization task is performed by the guards within Nest.js. So guard may choose to accept or reject your request. For example, you can see currently client chooses to go to admin profile, but the token of the client is user token, right? So the user is not allowed to go to the admin profile, right? So that is why the guard has rejected this request, and this request will not proceed forward. But similarly, if you see, if you go to the same link of admin profile with the admin token, then the guard will allow you to do that. This is one of the very simplest example of how the guards work. You can make it as complex as you want. For example, checking the token from the database or performing all sort of operation to verify if a certain request needs to be provided access to a certain route handler or not. So it can be as simple as this, or it can be as complex as you want it to be. So let's move ahead and get a bit of its practical. Okay, so let's move ahead and does some sort of practical with the guards. So if I come here and I do this nest generate guards and user. So I told you about that we can use Nest CLI to generate some sort of boilerplate code for any of stuff. We learned how to generate the code for controller, provider, module, and as well as an entire resource. But we can also do generate middleware or a guard as well. So let's move ahead and do this. So if I perform this command, you can see I already have the users directory in source folder, right? But I don't have any of the guards folder here. Okay, so let's wait a second and let this complete. So you can see the completion of the commands. You can see it created src user.guard user.guard.ts, and then this is a testing file. So if you go here and see, this is the code that it gives you. Okay, so here you can see actually I am having end of line error, so let me change it to lf and hit save. Okay, so you can see that we have can activate execution context and injectable coming from NestJS common and observable from RxJS. So this class, you can name it anything you want, but since we are in user module, so we have named it as so the NestJS CLI here has named it to user guard, and it has to implement can activate. So this is the must thing to do. So whatever, if you are planning to implement a guard, you have to make sure that you implement this can activate class. Okay, so this particular class has this method and this has this variable of context. So this context variable is of a type of execution context. So Nest.js actually has a concept of execution context, and I told you when we were talking about middleware has no knowledge of execution context. It doesn't even know where the request is going to go next. But guards have some sort of knowledge, and that is why it is very much useful to not use middleware for your authorization purpose, but use guards for your authorization purpose. Okay. So this particular method can return any of the three types: boolean if your code is synchronous, or promise or observable boolean. These are two boolean if your code is asynchronous. So we will make things simple and remove this for now, and this let's keep things simple as much as possible for our starters. So I will not be explaining like very complex scenarios of authentication and authorization. I will try and create an entire new series for that. The concept of this video is to explain you how the guards work mainly, right? So that you know the purpose of guards and how they can work, and you can move ahead and make it as complex as you want, as I explained earlier. So let me explain this a bit, right? So this context, if you go into the Nest.js, Nest.js not only have HTTP, it also gives you like WebSocket, Socket.io, RPC, and you can choose the context based on what kind of operation or what kind of protocol you are utilizing. Just like HTTP, there are multiple other protocols as well. I will also be covering this execution context in entire detail, but I will give you a minimal knowledge so that you don't get confused what it is used for. So let me show it to you through Postman as well. So as you can see in the Postman, we have this HTTP request of these types, right? HTTP is a protocol entirely. Similar to that, you have GraphQL, RPC, WebSocket, Socket.io, MQTT. So this execution context helps you determine what context your request is coming from, and then depending upon that, you can perform your operations for your authorization, right? For example, you would have sockets running, right, for your real-time communication, and that sockets would be utilizing a different kind of authorization techniques, not similar to your HTTP authorization techniques. So you can see if I go here, context dot, you can see I have access to these things, right? Switch to HTTP, switch to RPC, switch to WS. WS means WebSockets, and I can also get access to this get type. So if you want, you can perform something like this as well. Context dot get type HTTP, and if it is HTTP, then you perform this operation, and if it is WebSocket, then you perform this operation. This is what I was trying to tell you, right? You can perform different types of authorization techniques depending upon what kind of protocol you are using and in which context the request is coming from. So let's try and not make it as this complex, since we are assuming we are using HTTP, so we don't have to like make all of this conditional stuff. So let's just try and get the context here and get the request and try to log the request out like this and hit save. So now we have created a guard. It is not yet implemented. Let me tell you one more thing. If this can activate returns true, then that means the request is allowed, and if it returns false, then that means the request is rejected. So let's move ahead and try to implement this guard. So the guard is supposed to be implemented on your either on your route controller, or it can also be implemented globally. So for now, I will try and implement it on the route controller. So here I would, let me just change to LF. Okay. So now let's try and implement it on this request, like a very simple one. So if I do this use guard like this, so this use guard is also supposed to be coming from NestJS common, right? Most of our basic stuff is coming from here, and then I have to implement user guard. The name got a bit similar, but you understand, you can name it anything you want. So I have now imported it from user guard file. So if I hit save now, then the request should be logged out from our guard. Let me go here and copy this and paste here, and it is a get request, and let me see if it is reloaded. Yes, hit send, and you see the request is logged out, so we get a clean log of whatever the request is coming from. See, request. So what else we can do here? We can create some sort of like dummy authorization stuff. So if, let's say, check for bearer token in request header equal to Shamil token. Let's see if AI gives us a clean code of that. I think it is just generating the comments. So if request dot headers dot authorization, let's see something like this. Yeah, now it gives me something. Let's see if it works. I need to understand the token here. What is the token? And I also want to verify if this even exists or not. So I'm trying to log this out as well, like this, and remove these comments and the previous log and hit save. So let me go ahead here, and what is this? I'm trying to send a bearer token, right? So if I come here and go to the authorization and choose this as bearer token and keep it Shamil, and what was the Shamil token, okay, and hit send, and come here. So see, the authorization header gets bearer Shamil token, and the value of the token is Shamil token. So if it is not Shamil token, then it will not allow it. But since I am sending it right now, so it is allowing it. So let me change it a bit and hit send. So see, now we get forbidden resource, error forbidden, and status code 403. So we have implemented some sort of authorization technique where if the guard is implemented on the particular route handler and it does not contain this token, then the request will not be allowed. So this is a very simple implementation of how the guards can be implemented. Let's remove the logs. This was one log and this is the second log. So this is how we have implemented our guards.